section 3.2, Logarithmic Functions. Today what we're going to do is we're going to graph logarithms, but we're also going to solve and do some evaluating of logarithms and kind of this first introduction into logarithmic functions. The first thing though is what I want to really do is I want to graph, and the reason is because I want you to realize the similarity between exponential and logarithmic. And so what I want to do is just start with the parent function of the f of x equals 2 raised to the x power of the exponential. So this is the one we did the other day when negative 1, 2 to the negative 1 is 1/2, 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8. And all you're doing is because your base is 2, you're just doubling those values. So you have that horizontal asymptote at the x-axis. And so that's what we're looking at. Now, with a logarithm, the thing is that all of these points that we just plotted, because they're inverse, they undo each other, they just flip. So that point that you had at right here at negative 1 1/2 will now become 1/2 negative 1. So it'll be down here. The point 0 1 becomes 1 0. The point 1 2 becomes 2 1. The point 2 4 becomes 4 2. And the point 3 8 becomes 8 3. And so with them being inverses of each other, and so here's your parent function table here. We're at negative 1 0 1 2 and 3. You're at 1/2 1 2 4 and 8. Over here, since this is f of x, let me call this g of x, since they're not the same. If I plug in 1/2, I get an output of negative 1. If I plug in 1, I get an output of 0. Plug in 2, I get an output of 1. Plug in 4, get an output of 2. And plug in 3, get an output of 8. So now when you're plugging these in, oops, that last one I wrote the wrong way. Sorry about that. If I plug in 8, I get an output of 3. So if you plug those values in now, that's what it evaluates to. So what we have now is you have a vertical asymptote at x equals 0, and you can see if we graph this on the calculator, you'd be able to see that it reflects over that line of y equals x. So that's a logarithmic function, and we're only going to be doing base 2 on terms of graphing. So if you ever forget these parent function points, really it's the exponential, but it's just switched in terms of your x and y value. So now when you have to graph a function such as this one, f of x equals log base 2 of x plus 1, we know this goes 1 unit to the right. And so now we want those points from the parent function that we just did. So you can go back and look. We want the 1/2 negative 1 1 0 2 1 4 2 and 8 3. So let's plot those points. And so there's your parent function, and we want to take all these values and shift them over to the right 1 unit. And so just like you had a vertical asymptote at x equals 0, the same thing's going to happen here, except now it's shifted 1 unit to the right. So when you go to draw your graph, just make sure you don't cross over that line. And there you go again. Alright? And so for a lot of you just plug in points in, this is going to be very difficult because of what you're trying to make work out nicely. Kind of like square roots, but you're a little bit more familiar with square roots. So on D, this plus 2, this is not in parentheses. If it's in parentheses, then yes, it would shift to the right, or sorry, to the left 2 units, but it's outside that logarithm. So plus 2 means it's going up 2 units. So we get those parent function points on there again. And we're going to take all those values and shift them up 2 units. And there you go. Now on this one, that vertical asymptote does not shift because it's shifting up, so you're okay there. So just make sure you stay close to that line and not intersect or cross over it. Okay, so that's how you can graph logarithmic functions, but once again, you have to know what the parent function is to be able to do that. And you know the parent function, even if you forget it, you know the parent function by going back to the exponential function of 2 raised to the x power. So kind of the next thing that we're going to go into is really starting to evaluate some of this stuff. And so on this, we have the definition of a logarithmic function. And so the square root of 36 is equal to 6. And we talked about this the other day, is that what does that mean? That's 6 to the second power is 36. And so where's that 2 come from? That's the index of the square root. So 6 squared equals 36, and the square root of 36 equals 6 is the same thing. We're writing one as another. And then so when we look at this definition of a logarithmic function, whoops, we're missing a part here, so didn't come off for some reason. This is x equals a raised to the y power. Sorry about that. And so for all x values greater than 0 and all a values greater than 0 and a cannot equal 1, then we have a logarithm y equals log base a of x equal to x equals, if and only if x equals a raised to the y power. That IFF you should have seen in geometry, it stands for if and only if. And all that means if and only if. And that stands for that it works both directions. So you can take a logarithm, write it as an exponential, or an exponential as a logarithm. And so those stipulations that we had earlier on in terms of your exponential function, and you can go back and look at that, we talked about this a value being greater than 0. So with a logarithm, your base of a logarithm has to be greater than 0. You won't have a base of a negative. A can also not be 1. So that same stipulation that we talked about with exponential is true with a logarithm, but now when you look at this, where is the a located? It's the base of the logarithm. So that value has to be greater than 0, cannot equal 1. The x value must be greater than 0, and we talked about that as well when we did exponential, is that x value, that output has to be greater than 0. So same thing has to be true with the logarithm, which is going to be important because when we start solving this, we're going to solve for this x value, and we got to make sure we only include solutions that are greater than 0. Okay, and the y value can be all real solutions, your domain of the exponential, but your range of the logarithm. So that can be all real numbers. So when we start evaluating these, what are we looking at here? All right. First off, before we start evaluating, let's just talk about how we rewrite these. One of the biggest things I said in class is that when we start doing this, I'm going to say a term or a phrase over and over, and it's a logarithm is an exponent. So if you look at this, okay, as a logarithm is an exponent, so once again, let me rewrite this. A raised to the y is equal to x. And we say a logarithm is an exponent. This logarithm right here is equivalent to y. What is y? Y is the exponent. And so a logarithm is an exponent. So when you go to look at these and you go to rewrite these, we want to take the logarithmic equation and write it in exponential form. Well, your base is 5, so your base of the exponential is 5. 3, a logarithm is an exponent, so that's the exponent, and then the 125 is 5 to the third power. And so that's rewriting it in exponential form. Same thing over here. Base is 4. The exponent, logarithm is an exponent, is -2, is equal to 1/16. And it works the other way as well. Now we have it as exponential. So when we go to write it as a logarithm, we're going to say log base 3, right, of 81, and a logarithm is an exponent, so it's equivalent to the exponent of 4. And same thing on this side, log base 8, the base is what's being raised to the power, log base 8 of 2 is equal to the exponent of 1/3. And so if you keep kind of repeating that, a logarithm is an exponent, a logarithm is an exponent, that's what we're representing here. So the last couple slides I'm actually going to have you guys do is going to evaluate and solve. So how do you solve or evaluate what's log base 2 of 32? Well, really what you don't know is what it's equal to, which is x. So if you kind of ask yourself that question, 2 raised to the x power is 32. what is the exponent that makes this make sense? And the answer is 5. Alright, 2 to the 5th is equal to 32. And that's how you answer a logarithm. Same thing over here. 3 raised to what power is going to give you 1? Well, 3 to the 0 power gives you 1. Alright, and then on the last one, I have 9 raised to what exponent, because a logarithm is an exponent, is equal to 3. Now this one's a little bit more challenging, is that we know it's not 1, because 9 to the 1st would be equal to 9. 9 to the 0 would be equal to 1. So it's somewhere in between 0 and 1. Well, we start looking at our rational exponents. So what if we go 9 to the 1/2? Well, what's 9 to the 1/2? That's the same thing as the square root of 9, which is 3. So there you go. Alright, so this is equal to 1/2. Remember, we talked about this the other day. When you guys are doing, things raised to a rational exponent, remember, these are radicals. So x to the 1/2 is square root of x. X to the 1/3 is the cube root of x. Those are things that you definitely need to know so that you can work backwards on some of these logarithms. Alright, and then the last thing is, to kind of continue on that idea, I'm going to change the directions to solving, but you're still doing the same thing when you're looking at this. Log base 3 of 81 is equal to x. Well, we're solving for the exponent. So what value of x is going to make this work? 3 raised to what power? So this answer is x equals 4. And so there's really 3 values that I can ask for. So on all 3 of these, I'm asking for a different x. This one, I was asking for the exponent. Alright. On the next one, I'm asking for the value. So this is 2 raised to, the logarithm is equal to the exponent, for what value of x? So what's 2 raised to the negative 3? Well, negative exponents are reciprocals, so x is equal to 1 over 2 to the 3rd, which is x equals 1/8. And then on the final one, once again, we have the exponent. This time we're missing the base. So x raised to the 1/2 is equal to 4. Now some of you might be able to think about this in your head because it is 1/2, it's the square root. But if we want to solve this kind of mathematically, we could go ahead and square both sides, because 1/2 squared would just be x to the 1st, and 4 squared is 16. So square root of 16 is equal to 4, and that's why that works. So really, once again, this is the kind of general introduction to logarithms, starting with the graph of logarithms, understanding what the parent function is, that they're just inverses of the exponential function. Once again, still using transformations to graph these. And then kind of moving on to, okay, what is a logarithmic function? How do they compare to the exponential? And once again, they're inverses, so knowing how to rewrite them, just like you did with square roots and squares. And then doing a little bit of evaluating, once again, solving or evaluating for a specific logarithm or a single logarithm, and then doing a little bit of solving for the different values that I could ask for. Alright, that is it. Thanks.